Hello and welcome back to another OCR AS A-level computer science video. This time we're going to look at topic 3, exchanging data. This is part 1 for the workbook answers. Okay, as you can see here, it's broken up into 5 parts and we're going to be focusing on this time exchanging data. Now we're going to concentrate on the first 12 questions, as you can see here, ranging from 1 mark down to 10 marks, but it's quite a big topic, this one. It goes all the way up to 29 different questions. Okay, so we'll start off with the first 3 questions. This is to do with compression. So 1, state what is meant by compression. 2, identify the 2 types of compression that can be used. And 3, explain why lossy compression is not suitable for text files. So let's have a little look. Number 1, for 1 mark. Compression is the process of reducing the size of a file or data to make it take up less space on a computer, or to make it easier to transmit over the internet. It will be quicker to send a file if it's smaller, okay, generally speaking. The 2 different types of compressions are lossless compression and lossy compression. Now lossless, this type of compression reduces the file size without losing any data. It's like packing your suitcase more efficiently without leaving anything behind. That's lossless. But lossy compression, this is compression method reducing the file size by removing some data permanently. It's like squeezing a sponge to remove excess water, but some information gets lost in the process. Okay, and we'll talk more about that. Explain why lossy compression is not suitable for a text file. In terms of a text file is made up of lots and lots of words, or it could be a text file in terms of computer code. Now, it's not ideal for text files because they contain important information that you don't want to lose. When you use lossless compression on text, it may remove some details to make the file smaller. This can result in significant loss of readability and accuracy. For example, important words or letters might be distorted or completely removed, making the text difficult to understand. Lossless compression, on the other hand, retains all the original data, as we've mentioned here, making it a better choice for text files where every word matters. Okay, so if you've got a block of text and you start removing words from it, it might become very, very difficult to read and difficult to understand. For question 4, consider the phrase, every day, in every way, I am getting better and better. This is for 10 marks, so why is it 10 marks? A, encode the message using run length encoding. B, encode the message using dictionary encoding. And C, explain, based on this phrase, which encoding method is better and why. Okay, so we'll start with run length encoding. So I've encoded the message here, and let's have a little look at what it actually is. So run length encoding is a simple form of lossless data compression, where consecutive repeated characters are replaced by a single character followed by the count of repetitions. Okay, typically RLE is applied to sequences of characters or pixels. Great for pictures. If we've got a sky that's one particular blue, it would be great for compressing that sky. But it also can be adapted for text. But here, because we've got very few characters that are next to each other, we've got quite a big encoded message. For example, capital E appears once. A V next, then an E, then an R, then a Y, then a space, D, A, Y, comma, space, I, N, space, E, V, E, R, Y, space, W, A, 1. Okay, comma. So it's all single characters until we get down to getting, okay, where we'd have a 2 for T. T would equal 2. And then, of course, in better and better, we would have T2 and T2. Now, of course, better and better appears twice. In and in, you could argue, appears twice. Every and every appears twice. But it's not really how RLE works. This would be our new phrase, our new encoded sentence. But based on the original, we're meant to be compressing this file, but we've actually almost doubled it in size, going from 55 characters, which is what this is, including spaces, up to 104 characters. So realistically, if we scale this up, it would be a lot slower file to download. So realistically, if we were to scale this up, it would be a much slower file to download. Okay, so that's RLE. Not particularly applicable for this phrase. But here we go, we've got dictionary encoding now. Encode the message using dictionary encoding. So dictionary encoding involves replacing words or phrases with a numeric code from a predefined dictionary. I've created a little dictionary here with 11 different values. So every as a value with a capital E, day as a value, in, every, way, value 5, am 6, getting better, comma, and as a value of 10. So all I need to do there, as long as I've got the dictionary sort of linked to the phrase, I can simply encode the message 0 for every day, comma, 9 in every way. So every day in every way, I am getting better and better. And that takes up 15 characters. Of course, it comes with a dictionary, but that has 15 characters. Okay? So a little bit about it. Dictionary encoding assigns a unique number to each character. We've just said that, reducing the size compared to the original message. This method is useful when dealing with a limited character set like the ones in this message. Okay? This example uses a simple dictionary with assigned values. In practice, dictionary encoding algorithms often use more sophisticated techniques for assigning code, like if you want to have a research of this, like Huffman coding, to further optimize the compression. Okay, so I think we've established which one's better, but I'm just going to go into a little bit more detail on this. Okay, so dictionary encoding, what is it? It's good when you use the same word or phrases a lot. Okay, RLE, good when you have long rows of the same letter or symbol. So to conclude the phrase, every day in every way I'm getting better and better, using a dictionary would probably work better because it has some repeated words like every and better. Okay, so you could make them into shorter codes, but if the phrase had lots of the same letter repeated over and over, then RLE might be better. It depends on what is in the phrase. A different phrase might warrant RLE. So just to recap, dictionary encoding, if you think of this like a secret code where you replace repeated words with shorter symbols or numbers. For example, if you say banana many times, you might write down a code for banana instead of writing it out every time. This method works well when you have the same words or phrases repeated a lot in a message. Okay, and RLE, imagine you have a really long line of the same kind of sticker on a page, like a long line of smiley faces. Instead of writing out each smiley face, you just write the number of smiley faces and then one smiley face. So instead of writing 7 faces, you write 7 face. Okay, this works well when you have lots of the same letter or symbol repeated many, many times. Okay, so that's a difference. So I think we've established for this that dictionary encoding would be the best. Okay, we move on to encryption and hashing, and in particular encryption keys. Here we go. So state what is meant by an encryption key. Well, an encryption key is a piece of information used to encrypt and decrypt data. It's like a secret code that transforms plain text into readable ciphertext and vice versa. The security of encrypted data often depends on the secrecy and complexity of the encryption key. Okay, state what is meant, for 1 point, state what is meant by a hash function. Well, a hash function, rather more than 1 point, but a hash function is a mathematical algorithm that takes an input or a message and produces a fixed size string of characters, which typically looks like a random sequence of letters and numbers. The output is called a hash value or hash code. Hash functions are commonly used in computer science for data integrity verification, password hashing, and various other cryptographic applications. Okay. For 4 marks this time, describe how an encryption key could be made more secure. Okay, so let's have a little look at this. So what can we do? We can increase the key length. Longer key generally provides greater security. Using keys with more bits increases the number of possible combinations, making it harder for attackers to guess or brute force the key. Key generation. Keys should be generated using secure random number generators rather than predictable algorithms. This ensures that the keys are truly random and not easily guessable. Key management. Proper key management practices involve securely storing and distributing keys, as well as regularly rotating or updating them to mitigate the risk of compromise. Okay, of course, key encryption. Encrypting the encryption key itself adds an extra layer of security. This means that even if an attacker gains access to the encrypted data, they still need the decryption key to access the original information. And then finally, multi-factor authentication, combining encryption keys with additional authentication factors such as passwords or biometrics, strengthens overall security. Okay, so that is that. But then down here, we're waiting for this to happen. Explain for 1 mark the difference between encryption or hashing. Well, here we go. Let's move the arrow a little bit. Difference between encryption and hashing. Encryption, it transforms data from plain text to ciphertext, making it reversible with a decryption key, while hashing converts data into a fixed size string, hash value, that's irreversible. Encryption is for confidentiality, while hashing is for data integrity and verification. Okay, so they're the differences. Okay, we finish off with databases. Now, there's quite a lot of databases in this section, but this is the first part, just sort of 1 and 2 mark questions. Okay, got a little people database on here. State what is meant by a flat file database. Okay, well, a flat file database is a type of database that stores data just in a single table. Yeah, like an address book, just a single table. Typically, it is a text file or a spreadsheet. In a flat file database, there are no relationships between the data stored in different records, and all information is stored in a single two-dimensional structure, basically a table. Okay, explain what a primary key is and why it is needed. Okay, again, we're still talking about databases. A primary key is a unique identifier for each record in the data table. It ensures that each record can be uniquely identified and retrieved, such as like a bank account number. It's unique to you, and nobody else using that particular bank has got the same bank account number. Okay, primary keys are essential for maintaining the integrity and consistency of the data in a database because they enforce uniqueness and provide a means to establish relationships between tables. Okay, state the role of a foreign key. Okay, we'll get into a bit more detail now with the databases. Well, a foreign key is a column or a set of columns in a database that references the primary key of another table. It establishes the link or relationship between the two tables in a relationship database. So you could have for a library, you could have a database of all the books, okay? And then you could have a database of all the customers who use the library or all the students who use the library. And then the relationship is basically when a student takes a particular book out, we can see that the tables are joined. So we've got a table for the library books and we've got a table for the students, okay? So that's a relationship database. But, as I say, foreign keys are used to enforce referential integrity, ensuring that relationships between tables remains valid. Okay, that would be a foreign key. And then finally, describe how Mrs. Alice Jones would be found using serial access. Okay, serial access involves sequentially searching through each record in a database until the desired record is found. So we'll start at the top and go all the way through. To find Mrs. Alice Jones using serial access, we'd start at the beginning of the database, we'd look at each record one by one, compare the name field of each record with Alice Jones until a record is found. Continue each process until the record for Mrs. Alice Jones is located. So that would be serial access. And that is it. There will be more questions on databases, and I will do another video on databases and SQL. But in the meantime, that is it. So thank you very much indeed for watching, and I'll see you in part 2 of this section. Thank you. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.